Okay guys, we are live and let's continue solving our task. So next task would be the following. So it's called partition labels. So you're given a string S and we want to partition the string into as many parts as possible so that each letter appears in at most one part. Note that the partition is done so that after concatenating all the parts in order, the resultant string should be S. Return a list of integers representing the size of these parts. So we have some string and we have 9, 7, 8, and 8. So the partition is this one, then this one, and this one. So this is a partition so that each letter appears in at most one part. So we can see that um, letter A appears 4 times here, letter B 3 times, and letter C 2 times. Here letter E 3 times, F 1 time, G 1 time, so on. A partition like this one is incorrect because it splits S into less parts. Okay. Here we have EC, BB, EC. Yeah, so if I take E, I should take all parts connected to this E, and also if I choose C, then I should take all parts. So actually it will be only one partition. So let's write once again our description. So we are given string and we want to partition the string into as many parts as possible so that each letter appears in at most one part. Okay, so we choose, for example, A, and we try to find the last index of this A. And after this, we are trying to take the next element and try to find the next most occurring, and we see that it's less. So we go next to A. We know that this A is already here. We go to B, B is here. We go to C, C is here. We go to A, C, and A once again. Okay. So I think what can we do here is to create a map with each letter and the last index. And then to have like 2 pointers. So one pointer will start from this one, and another pointer is going to the last position of this index. And it would be the maximum pointer here. Then we have another, and we check our last position. Okay, and here D. Okay, so let's do it. So we have our map with character and integer. And we are going through each character. And yeah, here we need index. Char at I and I. Then we need some I. That would be our beginning of our pointer. Let's try to imagine it. So yeah, so this would be our beginning, and this one would be our end. So we have another array like this. Let's say start here. And yeah, so as we start with first one, we also need end. So end would be map get as char at 0. And here, if start, no, if I equal end, else. And here we have list of our result. And we will return this. So let's imagine here. So we start with 0, and our I is also 0. And then I take from the map the last index of I. So the last index of I is here. It would be our end. And here I check. Then I is equal to end. No. So I is not equal to end. It means that I'm going to the next element. And also I should update my end with mass maximum between end and map get as char at I. Okay, here when they meet each other, so how I'm going, like I'm going to the B, right? It's still not equal, but B is less. So my end still the same. A, B. Then I have C. C is less than B. B, A, C, and now I have the same. So when I have the same, I should add to my result and minus start. And also update my start with end. Yeah, update my start with end. Yeah, and here, if yeah, so here if I is less than s length minus 1, it means that I can take the next element. I can update start with end plus 1, and here end would be equal to this element I plus 1. Okay. Okay. Here too also would be I plus 1. Okay, so let's run it. Check. 8, 6. Yeah, so here plus 1 probably. And let's try to have this test case. So it should be 1, 1, 1. Let's run with this test case. Okay, and let's also run with only one element. Okay, let's submit. All right, and we are done. So let's take a look at editorial. So yeah, so they have the same logic, and here as well. Yeah, the same logic. Solution. Yeah, so the same logic. Okay, so I think that's all for today. Thank you very much.